Exponents and exponent rules. This lesson is about positive, negative, and zero exponents, and it is also about the rules for handling exponents in operations. Starting with positive exponents, the exponent is the small number above and to the right of the base. It means how many times the number is multiplied by itself. 2 to the fourth is 2 times 2 times 2 times 2, which is 16. 2 to the third is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1 is always written just 2. So what could a zero power mean? Notice that each time we went down by a power, we divided by 2. Thus half of 16 is 8, half of 8 is 4, half of 4 is 2, and half of 2 is 1. So in fact, every time you have a zero power, it always equals 1. 2 to the zero power equals 1. Anything to the zero power equals 1. 1/5 to the zero power, if it's in parentheses, equals 1. xy to the zero power inside parentheses equals 1. But pay attention, if it's not in parentheses, the zero only applies to the last variable. So xy to the zero power equals x times 1. And x times 1 equals x. 5.723 or any other number to the zero power is 1. A negative number to the zero power is 1 in parentheses, but a negative number to zero power outside parentheses is negative 1. A negative power has a strange meaning. It means to change the base to its reciprocal and make the power positive. Thus, 2 to the negative 1 is 1 over 2 to the 1, or 1/2. 2 to the negative 2 is 1 over 2 squared, or 1/4. 2 to the negative 3 is 1 over 2 to the third, or 1/8. 2 to the negative 4 is 1 over 2 to the fourth, or 1/16. By doing this, we keep the pattern that we had before, that every time we go down by a power, we divide by the base. 2 to the negative fourth, as we already said, is 1/16. But what if the negative power is in the denominator? Then it needs to move to the top and become positive. 1 over 2 to the negative fourth, then, is 2 to the positive 4 over 1, or 16. A negative number to a negative power moves to the bottom of a fraction, but only the power turns positive, not the base. Thus, negative 3 to the negative 2 power is 1 over negative 3 to the positive 2 power, or 1/9. If the negative power is on the bottom of the fraction, it moves to the top and changes to a positive. So 2 over 3 to the negative 2 becomes 3 squared times 2 over 1, or 9 times 2, which is 18. Negative 3 to the negative 2 power with no parentheses becomes negative 1 over 3 squared, because the negative 2 power is not affecting the negative. Thus it equals negative 1/9. If a fraction is inside parentheses, the power applies to everything. So you turn the fraction upside down and make a positive power. So 2/5 to the negative third is 5/2 to the positive third, or 125 over 8. Now consider negative bases inside and outside parentheses. A negative base inside parentheses to an even power is positive. A negative base inside parentheses to an odd power is negative. A negative base outside parentheses to any power is negative. Thus, when there are parentheses, negative 1 to an even power, 2, 4, or 6, is positive 1. But if there are no parentheses, these are all equal to negative 1. On the other hand, negative 1 inside parentheses to the power of 3, 5, or 7 is negative 1. And just the same outside parentheses, it is negative 1. Now for rules for operations on exponents. First, a power of a power. The power inside the parentheses should be multiplied by the power outside the parentheses. You can see why in the example 2 squared raised to the power of 3. This means 2 squared times 2 squared times 2 squared, which is the same thing as 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 6th. The simpler way would be to simply multiply 2 times 3. Every time you see a power inside the parentheses and a power outside the parentheses, multiply the two powers. Now pause the video and try these examples yourself. Now that you have tried it, check your work. X to the negative 1 to the 4th power means x to the negative 1 times 4, or x to the negative 4th, or 1 over x to the 4th. X to the 4th squared is x to the 8th. 5 to the 3rd to the x power is 5 to the 3 times x, or 5 to the 3x. X to the 3rd to the negative 2 power is x to the negative 6th, or 1 over x to the 6th. The next rule is power of a product. When several numbers are multiplied together inside parentheses, apply the power outside the parentheses to each one. In this example, 2 times 5 is inside the parentheses to the power of 3. So this is 2 to the 3rd times 5 to the 3rd, or 8 times 125, which equals 1,000. This is the same as if we had multiplied 2 times 5 together in the beginning and done 10 to the 3rd, which is 1,000. Now pause the video and try the examples yourself. Now that you have tried it, check your work. xy to the 4th is x to the 4th times y to the 4th. 3x to the 3rd y to the negative 1 squared is 3 squared times x to the 6th times y to the negative 2. Thus we have 9 x to the 6th, but y squared goes on the bottom of the fraction. 5x squared is 5 squared times x squared, or 25x squared. 2x squared to the negative 2 power is 2 to the negative 2 power times x to the negative 4 power. Both negatives make those go to the bottom of the fraction, so 1 over 4x to the 4th. Now for the power of a quotient. This means apply the power outside the parentheses to both the numerator and the denominator inside the parentheses. In the examples, 2/5 squared becomes 2 squared over 5 squared, or 4/25, and 2/5 to the negative 2 power is turned upside down to become 5 squared over 2 squared, or 25 over 4. Now pause the video and try the examples yourself. Now that you have tried it, check your work. 2x over 5 squared is 2 squared times x squared over 5 squared, which is 4x squared over 25. A negative number inside the parentheses to an even power becomes positive, so we get 2 to the 4th times x to the 4th over 3 to the 4th times y to the 4th, or 16 x to the 4th over 81 y to the 4th. A fraction to a negative power turns upside down to become positive, so we get 5 over 7x to the positive 2, or 5 squared over 7 squared times x squared, or 25 over 49 x squared. 1/4 to the negative 3rd turns upside down for 4 over 1 to the positive 3rd, or 4 to the 3rd, which is 64. The next two rules apply only when the numbers have the same base. In product of powers, we multiply two numbers that have the same base so we can add the exponents. In the example 2 to the third times 2 squared, we get 2 times 2 times 2 times 2 times 2, or 2 to the fifth. So we can add 3 plus 2 to get 2 to the fifth. Now pause the video and try the examples yourself. Now that you have tried it, check your work. Add the exponents together, so x to the -2 plus 4 is x squared. Multiply numbers first when there are coefficients. So 5 times 4 is 20. Add the exponents of a for a 2 plus 3, so we get 20 a to the fifth. Multiply the numbers first, for 3 times -2 is -6. Add the exponents of m for 2 plus 5, and write the n, so we get -6 m to the seventh n. Multiply the numbers first. 5 times 7 is 35. Add the exponents of x for 3 minus 3. Add the exponents of y for 5 plus 4. So we have 35 x to the 0 power, y to the ninth. X to the 0 power is 1, leaving 35 y to the ninth. The last rule is called the quotient of powers. If the numerator and the denominator have the same base, you subtract the exponents. Look at the examples. First, 2 to the third over 2 squared. If you write out the factors, you can cancel two factors on the top and the bottom, leaving one factor on the top, which is 2 to the 1. Whenever the largest exponent is on the top, the final answer will be on the top. Thus we have 2 to the 3 minus 2 power, or 2 to the 1. Now look at 2 squared over 2 to the third. In this case, when you cancel two factors on the top and the bottom, you are left with a 2 on the bottom and a placeholder of 1 on the top. Whenever the larger exponent is on the bottom, the answer will end up on the bottom. Thus we have 1 over 2 to the 3 minus 2 power, or 1/2. Now pause the video and try the examples yourself. Now that you have tried it, check your work. In the first example, the larger power is on the top, so subtract 5 minus 3 for x squared. In the second example, the larger power is on the bottom, so we get 1 over x to the 5 minus 3 for 1 over x squared. In this example, rewrite 5x to the third. Now apply the power of 5 to everything inside the parentheses it touches. So 2 to the fifth, x to the 10th. The denominator is still 10x to the 7th. Now multiply 5 times 2 to the fifth, which is 5 times 32, for 160. X to the third times x to the 10th, add the powers together for x to the 13th. The denominator is still 10x to the 7th. Now divide 160 divided by 10, which is 16, and when we divide the same bases, we subtract the exponents. 13 minus 7 is 6, for 16x to the 6th. In the last example, add the powers of x for 2x to the power of 3 plus 2 over a denominator of x times y. This gives us 2x to the fifth over x times y. The only base that is in common in the numerator and the denominator is x, so we need to subtract the exponents of x to the fifth and x to the first. So 5 minus 1 is 4. We get 2 times x to the fourth over y. Please use these notes as you complete your homework. Thank you.